I know you know these guys. So as you lower the pore pressure, this horizontal stress decreases, and decreases proportional to that factor A, right? So this one is SH. What happens to effective horizontal stress? It's going to increase or decrease as you lower the pressure. Effective stress. Increase, I hear. I think I heard a decrease. No? It will always increase, okay? Effective stress, if you lower the pore pressure, is going to increase. And the vertical effective is also going to increase. It's going to increase even more, okay? But I'm not going to plot it over here. And finally, for this first part, what's going to happen to permeability? If I increase sigma h with depletion, what's going to happen to permeability? It's going to decrease. And this is what you would expect in almost all kinds of reservoirs, even if they are not coal bed methane reservoirs, shale reservoirs, tungsten reservoirs, any kind of fractured rock reservoir, and in general, almost all reservoirs, you will expect the permeability to decrease with time, because you are increasing effective stresses, you are making pores smaller, you are making fractures to be narrower, and because of that, your stresses are going to increase and your permeability is going to decrease. Okay, but now this rock is a cold rock, and that cold rock develops adsorption-induced deformation. So we're going to add the component now of adsorption and see what is the effect of that, the chemical part on this reservoir stress path. Pressure, is going to be any change with pressure? Not very likely, right? I mean, if you set your bottom hole pressure to this, I don't think there will be any change. Probably you will produce more fluids because now you are getting the fluid contribution from desorption, but you will not change the pressure. What about effective horizontal stress? Is that going to increase, decrease? What do you think? So now you are producing fluids. You are getting fluids out of the rock, and that's a process of desorption. So it's this path. You have less pressure, and less pressure is going to be less amount of source fluid. Less amount of source fluid, it leads to shrinkage. So you know your rock is shrinking as you're producing fluids. What do you think is going to happen to your horizontal stress? It will decrease. We don't know if it's going to be, for sure it's going to be lower than this point, okay? We don't know if it's going to go even lower than the original. We don't know that, okay? But just in this example, I'm going to assume, to make it more obvious, that this horizontal stress is going to decrease a lot. So now, because of this is with adsorption-induced deformation, our horizontal stress, effective horizontal stress, decreases. Our total horizontal stress decreases even more than one we had before. And what's going to happen now with the permeability? So if before, let's assume that this was the original state. Before we were increasing the horizontal stress and permeability would decrease. Now we are decreasing effective horizontal stress, permeability is going to increase. So in this case now permeability is going to go up, and we may stay there for some time. So now as a result, and this is something real, this is the only type of reservoir as far as I know that develops and exhibits very clearly this phenomenon that as you do depletion, the permeability goes up. And recently I got a research grant in order to explore this same type of phenomenon for shales. I don't know the answer yet, but organic shales should be similar to what we see with coals. One more thing, guys. I know we are very close to the time, but let's try to bring this same thing to the Mohr circle. If this is the Mohr circle, and as we have seen before, if we start with the condition in which this is sigma V and this is sigma H, we said that a depletion path would move this Mohr circle towards the right according to this poroelastic depletion path. So here we can see very clearly that both the horizontal stress and the vertical stress, they both increase, right? So this one goes to there, this one goes to there. Well, with this phenomenon of shrinkage and adsorption-induced deformation, what you would expect is that if we were to decouple these two phenomena, you're going to have the contribution of the depletion, the poroelastic contribution of depletion, moving the Mohr circle to the right. But if you add the adsorption-induced deformation, your horizontal effective stress is going to decrease, and it may end up somewhere over here, and your Mohr circle now is going to be this one, much bigger than the one before, almost there. That's the same point, okay? At the same point, something that could result into shear failure. And there is also evidence that in many of these places there is actually this type of phenomenon in which if you were to measure permeability as a function of time, and so this will be real with failure, shear failure, you will see that your permeability increases very quickly, but after some time it starts to go down, because when you get to shear failure, you will start to fail the rock. Some small piece of rock will come out and will plug in fractures or in pumps, and in other places will clog the well and will lower quite a bit the permeability. So your permeability is not going to increase forever, but if you reach this condition of shear failure, it's going to reach a limit, and sometimes even it can go lower than the original permeability. Okay, so we're done with elasticity. Starting Tuesday, we're going to talk about plasticity. Please remember to upload your abstract. I'm going to give you an extension until Monday, okay? In case you haven't finished that abstract yet. But if you finished it, just upload it, and I'll take a look as soon as I can. All right, thank you guys.